From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 388, recorded live Thursday, September 5th, 2013. This episode of Hansel Minutes is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, makers of GesturePak, a powerful gesture recording and recognition system for Microsoft Kinect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Dr. Neil Roodyn about vision-based computing.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and on Skype I've got Dr. Neil Roodyn. How are you?
I'm good, Scott. How are you doing?
I'm okay. I'm looking at a Kinect on my desk here, plugged into my PC, and I'm looking at a Leap Motion, neither of which I have used lately. And I'm feeling pretty sad about that. I'm not sure if I'm more sad about the Kinect or the Leap Motion, but the point is I'm not using Minority Report gestures in order to control my computer. But I have the hardware.
Yeah, but you probably don't have the software, right?
I'm starting to think that that's it. So I want to understand today what is keeping motion-based computing from taking off in the way that I think it should take off, and whether or not my head is wrong about it.
Yeah, it's a good question. I mean, I think the question of, is the hardware ready is probably a fair starting point. But I think there's also the question of, are we ready in terms of the way we use computers or the way we think about computers? I think a lot of things need to change. In the 70s, people had touchscreens. The hardware technology was there. Now, it was a lot rougher than it is now, but we were not ready to go to a consumer with a touchscreen. It was a rough experience. And I think, it took 10, 20 years to get to a point where we were even close to being ready. And I think vision-based computing, and that's really what you're talking about here with infrared cameras and sensors, is a different category of computing. Vision-based computing is going to create, a range of different experiences. Those experiences are still early stages. We're exploring what they could be. And I think right now there was obviously a clear rush to the gaming market. Kinect's, kind of history in terms of it being released as, from Project Natal for Xbox is very clear that it's focused on gaming, and there's a niche there where it makes a lot of sense, whether it's social gaming or multi-user experiences in front of a large screen, kind of living room or lounge room experience. That's a very specific marketplace where Microsoft has clearly done very well. Leap is an interesting one because they're trying to bring the focus closer to a personal computer world and a personal experience. And what does that mean? Well, I don't think anyone really knows what it means. I think that's fundamentally one of the challenges, is we don't know what does that experience mean. I mean, right now, if you think about that close 1 foot experience to your screen, you already have some very optimized over, 30, 40 years we've been working on experiences using keyboards. Over 20 plus years we've been working on experiences using mice. And you're trying to introduce a new input device, which probably does have a place, but the experience is still very rough. And so you're saying, well, hey, this is just sitting on my desk, I'm not using it. Well, that's because you're comparing something that's got a 1 or 2 year, experience lifetime with something that's got a 20 or 30 year experience lifetime. So yeah, there's a way to go. There's no doubt about that. But I think there's some very obvious, maybe to me, niche markets where this makes a lot of sense. And in the no-touch space where you really don't want to be touching a keyboard or mouse, healthcare is a clear one to me that there's some opportunity space here. Every time, within a hospital or a healthcare environment, someone touches a keyboard or mouse, really it needs to be cleaned down. And if you could interact with a computer without having to touch anything, there are some advantages to that. So I think there's some spaces where people can get some early stage wins, but I also think that there's a long way to go in terms of evaluating the experience and improving the experience, and I think it's going to be a long incremental process. Now, hopefully it won't be 20 years, but I suspect it may be 5 to 10.
So you're saying that the expectation I have of picking up a device at Best Buy, this consumer electronics store, and just dropping it on my machine, plug it in the USB, and then I'm off and running with the kind of immediate productivity that I'd have purchasing a mouse is an unreasonable expectation on my part.
I think it is an unreasonable expectation, yeah. And I think we're at the stages now where as a techie or a geek, it's our job to work out what is it that's missing and what is it we can do to improve this. What can we iterate on? What can we, do over the next 12 months, 24 months to make the experience a little bit better, or to at least hit some markets where there's an opportunity and say, hey, this is really cool if you were to use it for ABC, and just do those, get those things working. I mean, you probably remember, right, when the mouse was first introduced onto a PC, people were very kind of curious as to why. Why do you need this thing? What's the purpose of it? Should we really care? Like, I can do all my, my Lotus 123 and my WordPerfect purely keyboard driven. So what the heck? Why do I need this thing? So, and I think over time it became very clear that the mouse has a pointing device with a high level of granularity for touching specific spaces very easily has a place. But, there's lots of other devices that still stay in the niche. Like, think of, people use mice, but how many people use trackballs, or how many people use external tablets? And yet there's still very valuable input devices for certain markets. Like, if you're in CAD design, you would probably spend a lot of your time with a stylus in your hand, using an external tablet. So, but that's not for the everyday consumer. You could use it, but you don't.
So that brings up an interesting question. So just to give you a little lay of the land here, I've got my regular, what do you call this? Microsoft ergonomic mouse. Mm-hmm. I've got my keyboard. I have a Logitech touchpad. It's the Logitech 650. It's like a portable trackpad, right?
Yep.
I use that for scrolling around, 2-finger scroll. I'm a big fan of 2-finger scroll. And then on my left here, I've got a Wacom tablet that I use for Photoshop. But it's pretty clear that if you stack ranked these, including also the Leap Motion and the Kinect, the mouse is being used 95% of the time.
Right.
The trackpad it's being used maybe 5% of the time. Although if you were primarily a Mac user or a Magic trackpad user, you would find yourself using the trackpad 90% of the time. The Wacom's being used as a specialized input device. It's like, I would look at it like, you've got your Xbox controller that you use all the time, and then you've got your driving controller that you use when you're playing driving games. Do you think that the kind of vision-based technologies like Leap Motion and Kinect will ever reach the kind of general purpose use as a mouse or a keyboard, or will they always be the Wacom tablets of of interaction?
Oh, that's a tough question. I think that there will be an increase of their usage as people discover new ways of creating software interfaces for them. Whether it will ever exceed in terms of the 1-foot experience sitting right in front of your computer, whether it will ever exceed the mouse and keyboard, I doubt. But for specific scenarios, I suspect it very much will. I think vision-based computing gets much more interesting beyond 1 foot, and I think that's where Kinect really has an opportunity beyond Leap. The Kinect type devices where you can be 10 feet away from your computer and you don't have, the keyboard and mouse right in front of you, and yet you can be interacting with it. I think we're not really thinking about those things because we're so stuck in this very personal computer world. And I think this actually leads to a much bigger conversation around, are we moving from an era of personal devices, not that they're ever going to go away, we'll always have personal devices, but into an era of many more shared devices as well. So, the living room is already breaking ground in that space where we have shared computing experiences. Is that going to be something else that we will find in other parts of the house, in other parts of the workplace? You think of meeting rooms, and you walk into a meeting room. You really want to have a shared computing experience within that meeting room where everyone can engage with the screen, the projector, at the same time, and share that experience. And I think we're starting to nudge ourselves towards that. And I think vision-based computing really helps, because with cameras, you can identify who the people are in that space. Maybe not personally identify that this is Scott and this is Neil, but you could say, hey, there's two people in this room, and the guy on the left is moving something and the guy on the right is doing something else, and you can identify who did what, and then visualize that somehow on a screen or on a display. And I think that's where it gets really interesting. So I think, yes, possibly you're right, that initial experience with the Leap is a little disappointing, because the space they're trying to conquer is actually probably the hardest space to conquer, whereas Kinect is taking a slightly less challenging space in the distance that it's approaching. And I think you very much need to think, when you think about vision systems, what is the distance from the interface that person is? Because when you get really close, you have to question, why not use touch? Why not use a mouse? Why not use a keyboard?
Mm-hmm. Yeah, one of the things that I tried to use the Leap for and tried to make it a part of my day was scrolling, because I want to be able to lean back and then kind of make a flippant upward hand motion to indicate I want to scroll within a web page that I'm seeing. And it seemed to me like that was a very simple, constrained motion that is very unambiguous. And the software in the Leap had a lot of trouble understanding that, because they wanted a within a few inches motion with just one finger or two fingers spread apart in a very distinct V, pushing forward and kind of jabbing forward into the air, flipping up, and then moving in a circle. So what I took as being a very kind of off-the-cuff hand flip, in any random direction, they wanted an extremely precise motion. So they needed precise input to do what I wanted, to understand my intent.
Yeah, and I think that's a lot of that is around context as well. So understanding the context that you're in, and again, we're early stages of this, although it's something that people have been doing research in for 40 years plus. But contextual computing is something that we're going to see more and more of, and I think we're already starting to see in terms of some of the applications that you have on your personal device. Like, your personal device knows where you are, so when you look up a location, it says, do you want to know how to get here? Well, I know where you are, so I can get you to that location. And the context of you being in front of your computer and what you're working in, what does this hand movement mean? Well, I think the software that's understanding that needs to know, are you in Excel, or are you in Visual Studio, or are you in Photoshop? And they may all mean different things depending on your context. Or are you on a Skype call with your friend?
Yeah.
You're just waving to your friend's child. They're all different contexts.
Yeah, we've all seen that lack of context, but my wife will say something about the Xbox, but the Xbox hears her say Xbox.
Right.
And then wackiness ensues. And context can mean so many things, right? I mean, context can mean, if the Xbox knows that there's suddenly 40 people in your house, and there's not usually 40 people in your house, well, you're having a party. Mm-hmm. So then maybe its context is going to change more towards things around party-based gaming and music. But while it's really easy to say that from a business requirements perspective, it just takes one sentence. The amount of work required and the privacy concerns around something as simple as, hey, I noticed that there's more people in your house than are usually there. In a movie, we would find that to be amazing. Right. In real life, we would find that to be super creepy.
Yeah, and I think that's, the conversation around context, although we're a little off topic, is an interesting one, because people want it but don't want it. It's a bit like, people want to have computers that understand their daily lives and can help them further and really be a true personal assistant. It's kind of funny, you talk about the context, and you think about things like the personal assistants that we used to have with PDAs, and they really were not very assistive at all. And yet, really, in order to have the full capability to assist you, they need to have a lot of personal information. And then you counter that with, yeah, but I don't want to give these guys all my personal information. I don't want them knowing where I'm shopping. I don't want them to know that I play tennis every Wednesday afternoon. That's none of their business. Well, if you don't give that information, you can't get the context. And so, it's that trade-off. And I think it's going to be interesting to see how companies business-wise play off over the next 10 years with that, because, some companies are very clearly saying all your data is ours and we'll do what we want with it, and we can provide some extra contextual smarts because of that. And some companies are saying, no, it's all very much opt-in, and you'll have to provide this information if you want to provide it, and we can be a little bit smarter if you do provide it. So, yeah, it's a complex issue, and it's not just a technology issue, it's a social issue, it's almost a political issue now as well.
Yeah. I think that when I think of my favorite sci-fi movies where someone wakes up in their kitchen and has this great conversation with their personal computer that's on all of their walls and they hear about their weather and all those things, I don't think anyone thought that would be in the cloud. Everyone just assumed that would be in the house.
Right.
You'd have a personal cloud. I don't think anyone thought multinational corporations would get that context to work through things like Google Now without, by allowing that to escape our house and go into the world, and then they control that. But that is definitely off topic. I'll have to do another show on that. But let me understand vision-based computing and how it works at the hardware level. So I understand that the Kinect, which is on right now, I have a Kinect for Windows, which I think is different than the one for the
slightly.
Xbox.
Yeah.
Okay. So it's shooting infrared beams at me all the time, like a dot pattern of infrared dots.
Correct. You're being bombarded by infrared. Well, the whole space that you're in is being bombarded by infrared beams, and then the reflection from those infrared beams is being picked up by camera on the Kinect device, and that's then detecting what's in the space.
So then the size of the dot, is it the size of the dot that's telling it that, this dot is closer, therefore this is bouncing off his hand, which is closer? Or is it something about the speed at which that the light comes back that tells them that?
Actually, I have no idea. I'm a software guy.
But it's something like that, in the sense of far away dots are far away. So
it has depth perception, and of course it has a traditional camera on it as well, color camera, and by getting the image from the color camera, getting the depth image at the same time, and using some smart software technology, we can start to determine what is in this space, and we can do some pretty cool things with that in terms of saying, look, I can see something that looks like a person. Let's try and recognize where their head is and where their left arm is and where their right arm is and where their legs are. And then, look, they're moving. Now, they're moving their left arm to the right. Okay, that maybe is a gesture. Let's have a look at my gesture recognition table and see whether the left arm moving towards the right indicates a gesture. Oh, yes, it does. What should I do based on that gesture?
And these are higher and higher layers of abstraction, but at the lowest layer, you're getting back an array, kind of a matrix of data from the Kinect that indicates, here's the color stuff that I saw, the color pixels, and here are the depth pixels.
Correct, yeah.
And that's it. Like the hardware doesn't give me your left hand is moving right to left or whatever.
Correct, that's all software.
Okay, and this is where I think things fall down, because it seems to me like both the Leap and the Kinect have amazing hardware, but from a software perspective, when I've sat down and tried to program the Kinect, and they're like, "Here's an array of ones and zeros." I'm like, "Well, gosh, okay. Well, where's the hand?" And there's the SDK, which gives you some more context. But I think we've all had that experience where we've been using a Kinect, and then suddenly it'll take maybe like your left leg and then just throw it over your shoulder, and it's get completely insane just for like a split second. You know what I mean?
Right.
You're doing your thing, you're jogging in place, and then your leg flies up in the air.
So that again is a software challenge. What the Kinect does within the Kinect SDK is that it infers positions if it can't detect exact positions. So, and sometimes those can be a little bit bizarre, and sometimes the exact position it thinks it's detecting is the bizarre one. In fact, the inferred one makes more sense. So you can use software to determine that. In fact, there's series of getting started guides and hands-on labs that I built with the Kinect for Windows team that shows you exactly how to make some kind of sense out of that. So, there are proportions that a normal human body has, and you can look for those proportions, and you can detect the skeleton that's being recognized in front of you. And if you suddenly see that the next frame, their knee is above their head, whereas previously they were standing up, that's probably an incorrect frame, so you should ignore it. And so there's a lot you can do in software to optimize and remove those really weird, as you say, kind of erroneous frames from the picture that you're using. It's where you get repeated weirdness that it will become a problem. So if someone is crouching down and their knees really are above their shoulders, you will have some issues there, because a typical skeleton recognizer will look at that and go, no idea what to do at this point.
So is this similar to voice recognition in the sense of the voice recognition gets better and better, the less possible things that can be said? Like, I've got a voice recognizer in my car that's like from the 90s. It's like whatever crap Toyota put in my car, but it only understands like 15 words.
So it's actually pretty good.
It's fantastic. It's never wrong.
Right.
Because it can only hear me say like volume up and volume down and stuff like that. And I've even made up like mumbly words that kind of had the same cadence, and it got it right. So I'm wondering, in the Kinect world, what you're describing is that the body is shaped pretty much the same for everybody.
Right.
There's only so many ways it could go. So you're basically saying you're going to constrain it by saying, we're going to assume people for the most part are not double jointed.
Correct.
And then start throwing data out, and that allows you to be more accurate?
Yeah. Yeah, and I think a lot of that's about filtering, but it's also, one of the things that Microsoft is doing is using machine learning algorithms to improve the skeleton recognition. And in fact, it's pretty similar to the algorithms that are used for speech recognition, similar to the algorithms that are used for machine translation, for translating languages from one language to another. It's really looking for patterns that recur and saying, yes, this is a valid behavioral pattern, and therefore makes sense, and therefore the skeleton is probably doing this. So in the 1.7 SDK that was released not long ago, the Kinect SDK, Kinect for Windows SDK, introduced two new interactions. One was a push or press interaction, where the hand, we're detecting a hand is moving towards the screen, and the other one is a grip interaction, where we're recognizing a closed fist as opposed to an open fist gesture. And those are both trained using lots and lots of video footage and depth footage of people interacting in front of a Kinect device, carrying out those interactions, and then using machine learning to recognize what does it actually mean, because people press in different ways. Some people will actually physically move their whole body and move their arm towards the screen. Other people will just tip their hand down towards the screen. And yet they both should be recognized as a press. And so there's a lot of work in terms of what can be done in software to improve the vision systems and the recognition of people's interactions.
Can you talk a little bit about the layers? Because I understand that I've seen the array. I've done the basic Kinect SDK stuff where it's like, okay, here's an array of ones and zeros, and that indicates the color data. Here's the depth data. What lays on top of that gets me all the way up to a gesture I can recognize as a press?
Yeah, look, that's a good question. So there's the streams of information that come in. There is a, as you say, a pure depth stream and a raw camera stream, and you can just pull those frames out, and then it's up to you to have fun with those. Beyond that, there's also a skeleton recognizer, and the skeleton recognizer will give you up to 6 skeletons that can be recognized in a space at a time. Now, we only have the ability CPU-wise to track 2 of them for interactions, but it will see up to 6. And then from there, you can do things like, okay, now we have the skeleton. The skeleton is all broken down into a series of limbs, so it's an array of components, if you like, of the skeleton. So you can see left elbow, right elbow, wrist, hand, head, shoulders, knees, toes. I think we know that song. And so taking that skeleton data, which each skeleton position, each component of the skeleton will have a position that changes each frame. You can then start doing your own gestures. So you could say, I'm detecting that the left arm is moving in relation to the head, and therefore doing a gesture. And actually, Josh Blake did a video on the Kinect for Windows blog recently where he's showing how to pick out some of those gestures by just detecting a hand position and a head position and saying, well, the hand is moving, closer to the head or further away from the head, therefore indicating some kind of wave gesture. So you've got that, and then above that there's also the Kinect for Windows toolkit, and the Kinect for Windows toolkit gives you a set of controls that already implement some of these interactions. So you can actually just pick up a control, and there's WPF controls and Direct2D, Direct3D, C++ controls that let you detect things like the grip gesture or the press gesture. And then there's controls built using those gestures that are a button control, a scroll viewer control, that out of the box will just automatically detect the interaction and work with it.
Okay, so you've got the color stream, the depth stream, the skeleton recognizer. Those are coming to you as frames. So I'm going to get like an array of body parts,
correct,
as fast as the system can give them to me. Are those body part or that body part array, is that coming from the Kinect hardware, or is that coming from some low level software layer?
It's coming from software layer. So the software is interpreting the depth stream and doing the skeleton recognition.
And then I understand that there's a near mode that was added in the Kinect recently, which is the I'm sitting in front of my computer mode as opposed to the I'm dancing in the middle of the room mode.
So it's a closer mode. Kinect for Xbox doesn't, is really optimized for that living room, lounge room type experience. It's not optimized for sitting closer to the computer. So Kinect for Windows provided a concept called the near mode, which really refocuses and does some recognition based on the fact that a skeleton will be closer to the Kinect device, and that could mean 1 foot, 2 foot instead of 10 foot from the device.
Algorithmically, what is the right way, or what are people using to detect things kind of over time? It's easy to be stuck in a while loop or a for loop and watch for a particular behavior that happens at an instance. But this is a stream of things where I might start moving my right hand at one point, and then in the middle of that right hand gesture, halfway through, start moving my left hand. So I've got things happening over time at different speeds that take different lengths of times, all of which might be meaningful to my application. That moves from the average programmer's understanding of for loops and the occasional link query into a pretty complicated algorithmic and math type stuff that they might not know how to write.
Yeah, it's fun, isn't it?
How do you do that, Dr. Neal?
Well,
do I need a degree and a PhD to do this?
Possibly, although probably not. The reality is that at the end of the day, you've got basic programming constructs, and you need to start building out patterns. And there's a couple of things you can do. At a low level, you can actually just start tracking position and noting that something is going in a direction. And so you say, okay, left hand is moving right hand is moving up. Is that going to continue for a period of time? Is that going to continue for a set distance? So you may only be looking for these two things to happen over a distance, or these two things to happen over a period of time, and then you can trigger your activity. But like I said, the other thing that's kind of where yes, you probably do need a bit more intelligence or a bit more practice or experience is in the machine learning side of things, which is where you're actually taking a lot of existing content or footage of people doing a certain behavior and then letting the machine go at it, see if it can work out using some machine learning algorithms, what is the commonality between these things. And the funny thing is, we don't actually know what at the end of the day, what is specifically the commonality. What we know is that percentage-wise, we have a high percentage result when you feed in 1,000 images or video footage of people doing this thing, that we now have a higher percentage success result based on the output, whatever that algorithm looks like. So, you could dig into it, I'm sure, and find out exactly what the details are and what it's starting to look for. But I certainly don't care too much as long as I'm getting a higher percentage result out of it.
Really? So machine learning, you're saying as an engine, we're caring less and less about what it's learned and more that it has learned it. Like you throw it thousands of video footages of someone making a press gesture and it draws a nice bell curve and it figures out that how accurate does that need to look, right? You could say, well, I want to catch all the outliers, and then you would catch some of the people doing weird press gestures, except it might cause false positives in other instances. And then that bell curve is built by the machine learning algorithm, and you don't care how it happened, it just happened.
Yeah, I think we shouldn't care as day-to-day developers trying to build something with Kinect for Windows. The details of how it happened. You should care that, hey, I now have a new interaction that's recognizable. Sure, it is actually, scientifically, it's really interesting to try and work out what is happening in there, because maybe we can build better machine learning algorithms from doing that. But at a high level, in terms of as a developer plugging into the Kinect SDK, we should say, oh, that's great. I now have this new interaction for press that someone else has done the hard work for. And that someone else is partly scientists, but also partly machine learning algorithms that have gone and optimized, this is the highest percentage recognition for that particular gesture.
Now, are there libraries? I think Carl Franklin has a library for Kinect, but I assume that there's lots of different libraries out there where can I teach Kinect what a gesture should look like? And if I just do it hundreds of times, it'll eventually learn? Actually,
Carl's got a really nice tool I think it's called Gesture Pack. That you demonstrate a gesture to it and record it a couple of times, and then it will generate the code for you to determine whether that gesture has been actioned in front of the Kinect device. It's really quite a sweet little tool. So yeah, I'd recommend having a look at that. There are a number of them out there, although I think Carl has really done a great job of simplifying it to kind of a and I guess it's expected of Carl, really, of a Visual Basic programmer's level. So, you can really take that thing and just use it, and as is, it works. And yeah, there are a lot more out there. There's a lot of open source libraries out there, and it depends how deep you want to go into it. Do you want to go into analyzing all the details of the interactions, or do you want to just, at a high level, get something that when someone waves in a certain direction in front of your screen, it performs an action? So, I think it really depends, again, on the context of your application and what you're trying to achieve. If you're trying to achieve something that's just grabbing people's attention in a shopping mall with a Kinect device, you probably don't need to have super detailed level of recognition, and if you miss 1 in 100 people's gestures, does it really matter? No, it's not critical. If you're trying to build something where you're actually going to be doing some kind of healthcare over using Kinect, well then yeah, it really does matter, and so you want a much more precise recognition system. And whether we even have that yet, I would be surprised right now. I mean, not with off-the-shelf hardware. I suspect the new device that was announced for Xbox One could be really interesting for that, and whether it's got, again, high enough granularity, I just don't know.
Yeah, I think that I'd love to see this for the deaf. I know there was a lot of excitement when Kinect originally came out that the deaf would be able to use this and have hand gesture recognition that was granular enough that you could have almost two-way translation between people doing sign language and people speaking.
Right.
But then they lowered the resolution before release, and it turned out it wasn't going to happen.
Yeah, and I think that's partly a cost issue, right? I mean, cameras cost money, and the higher the resolution, the higher the cost.
And the CPU.
And the CPU processing is expensive as well. Yeah. So, there's no point in releasing a product that you can't buy a computer to plug into and make it work. Whereas, obviously, over time, Moore's Law still exists. And although, probably slowing down a little bit in terms of people's capacity to actually utilize the processing power, then I think we'll see some of these devices with high levels of granularity being used more. There's a lot of processing power unused now in people's personal computers. So, yeah, it's a big opportunity going forward.
Yeah, I know. I was looking at both the Kinect and the Leap Motion. Leap Motion right now is using up 0.5% of my CPU. And if I wave my hand over it, it uses 3%. And in my kind of obsessive compulsive brain, I was like, 3% CPU? I don't have that kind of CPU to spare. But even right now, we're doing a high definition Skype plus audio recording plus Outlook and Visual Studio are all open. I'm only using 10% of my CPU. I think I probably have enough idle.
Yeah, you could probably spare 3%. Yeah.
Well, thanks so much for chatting with me today, Dr. Neil.
Oh, you're welcome. No, it's good to catch up.
Yeah, and any links at all you can give me to put in the show notes to point people towards some of the articles that you've done or Josh Blake have done on the Kinect for Windows blog and some of the things that you think people need to learn about vision-based computing. I would appreciate it.
Yeah, sure. I mean, the main one is really the Kinect for Windows developer site for developers, and I'll send you the link for that. And yeah, from there, there's a whole bunch of connections that will take you out.
Brilliant. This has been another episode of Hansel Minutes, and we'll see you again next week.